Hi, welcome back to Missing Chemistry. This problem deals with equilibrium and rice. If the Kp of the following equation is 2.4 times 10 to the negative 9 and the initial concentration of CO2 is 2 atmospheres, what are the partial pressures of the substance at equilibrium? Alright, so let's look at this. We've got a solid, we have a gas, and we have a gas here. So the solid is not like a gas or anything like that. So this is what we call a heterogeneous equilibrium situation. All right, so we're going to go ahead and get rid of those real quickly. And there we go. Now, let's go ahead and get this set up. So we're going to do our rice table. So we set up R for our reaction. And we get C plus, well, we don't have, I'll tell you what. C plus CO2, and then we have our forward and reverse reactions to make 2CO, carbon monoxide. So our initial concentrations, that's the I. Initial concentration for carbon is, we don't have one because it's a solid. So our initial concentration for CO2 is 2 ATMs. All right. And our initial concentration of our product is 0 ATMs because we haven't made it yet. All right, so the change. So again, we just X that out. The change is going to be minus X because it's going down. And we are increasing the positive 2x here because of our 2 right there. Now, the evaluation. So this becomes, this doesn't have anything to do with it, so we just kind of scratch these guys, all right? So this is 2 minus x, and this is 2x. Now, we need to remember that Kp is going to equal products over reactants, just like that. Okay, so let's go ahead and get this started. We're going to need to get some more space. We're going to go to the second page here. Yes. And so here we go. So now, remember, we'll put our rice table back up here again. R, I, C, and E. And we have C plus CO2 equals 2CO. And then, of course, we're getting rid of all this because this is solid. This became 2 ATM. This is minus X. This is 2 minus X. And, of course, the initial concentration was 0 ATM. The change is going to be 2 ATM because of the 2 in front of the CO. And there's our 2X there. So now we set up our Kp. So our Kp is going to equal the pressure of the CO2, the products over the reactants. And we're going to put a 2 there. Why does that 2 go there? Because you have a 2 right there. Okay, just to let you know. All right. So now we're going to put underneath, of course, our oopsie daisy. One small mistake here. Let me get my eraser here. Occasionally this happens. Sorry about that. I need to clear that out. I needed to rewrite this as PCO, not CO2. So now this is going to give us on the bottom PCO2. Now we got it. All right, so here we go. We know our Kp value from the problem said it was 2.4 times 10 to the negative 9. So we can get 2.4 times 10 to the negative 9 equals 2x from our table squared 2 minus x on the bottom. Now, here's a little trick. You may like it, you may not like it, but if k equals or is less than 1 times 10 to the negative 3, just throw out the x. I mean, you could do it with the x if you wanted to, but you can throw it out also. It kind of makes things a little bit easier because the x is not something like 2.4 times 10 to the negative 9th is such a small number, it's not going to really affect a lot of things. So we're going to throw that x out, and we're talking about this x right here. Not that x, just this x. Okay? So this is going to give me 2.4 times 10 to the negative 9 equals 2x squared over 2. So this gives me 2.49 times 10 to the negative 9 equals 4x squared over 2. Well, the 2 and the 4 will divide down, and this will give me 2.4 times 10 to the negative 9, 2x squared. So we'll divide this side by 2 and divide this by 2. And this will give me 1.2 times 10 to the negative 9, x squared. Then we take the square root of both sides, and this gives me x equals 3.5 times 10 to the negative 5th. Now it asked us to find out at equilibrium what were the partial pressures of the gases. So we'll start with P CO2, the partial pressure, is equal to 2 minus x. So our x is 3.5, right? So this is 2 minus 3.5 times 10 to the negative 5th. So this is going to equal, let me get my calculator here. Okay, so we're going to go 2 minus 3.5 equals 1.99999. And you know what? ATMs. And that's just practically, that's approximately 2 ATMs. Okay, so let's look at the partial pressure of the carbon monoxide. So PCO equals, and it's, of course, 2x, because of this x right here, right? So this would be 2x. So this would be 2 times 3.5 times 10 to the negative 5th. So when I punch that in the calculator, that gives me approximately 7.0 times 10 to the negative 5th ATMs. And that's your answers. Will you guys be snarly? We'll see you back here at Moosing Chemistry.